All right, so if you've been watching any of these, the theory is that we transitioned out of water. We were always a four-chambered heart, placental animal. Okay? But then, at some point, we had to stand up bipedal, and the hips had to evolve. It's all in the hips, okay? Now, during this time, you would think, well, okay, now we know there are marsupials that have hooves, okay? And this is where I think there's a transition in here. That's why I think there's a transition. Now, okay, now there's something else to confirm this further. Bam! The horned kangaroo. They just found this 2 weeks ago, okay? So at some point, when we transition from an antelope or an ungulate with horns into a marsupial, it diverged into two, okay? It diverged into marsupials that are bipedal and hooves marsupials, okay? Like the bilby, pig-footed bandicoot, all right? So then, after this diverged, you have a lineage here where it's placental, and then placental and marsupial. That diverges also. So you have a semi-bipedal primate, which are chimps. You know, they walk on all fours, and they can walk upright, okay? But they walk on their knuckles like any ape, okay? But they can walk bipedal. Rodents, they can stand bipedal. It's a primitive bipedalism, okay? This is why rodents favor the kangaroo, and there's marsupials that are rodents. You see what I'm saying? So here, when you have the rodent, you have the ape, okay? The kangaroo transitioned, passes genes into what we would be a common ape, you know? Okay, and from this antelope transition. Now, get this. When we transitioned from the ocean, okay, the theory is we transitioned from the ocean cetaceans into what would be walrus, you know, the pinniped with ivory still, all right? Well, there would have to be a transitional state in between there somewhere. Lo and behold, I found this guy, okay? Son actually found him. Odobenocetops. He's half walrus, half cetacean, or half whale, half walrus. It's a transitional stage in between. You see what I'm saying? Just like this horned kangaroo is a transitional stage after we get out of the ocean for a little bit and get legs, lose our hair, or start gaining hair technically. We lose our hair down here toward the end again. But that's why rodents are closely related to humans, because they evolved parallel from an ancestor, all right? But with transition, see, antelope can walk bipedally, all right? At some point, the hips are going to have to transition to give live birth, all right? So at this point, it does this, the kangaroo, through the marsupial, all right? But then you have marsupial, this guy here, having the antelope-type face and a body of an ape, kind of, into something like this, for instance, you know? I mean, there are transitional stages in between. We just don't have those fossils, you know? I'm sure they'll turn up eventually if they exist. Hardly anything actually gets fossilized. You got to keep that in mind. You have to understand it from a fundamental view. You can't make assumptions and look at everything from a number kind of view, because the numbers, they confuse things if you don't understand the fundamentals. It's hip evolution. And during this time, the hooves are going to transition into fingernails and toenails. All right, so the kangaroo passes genes, eventually transitioning into ape. There's also going to be, the hooves reduce. Okay, these are the rodents of the outback, you know. That's why they're kind of referred to as rodents, because technically they're related to the rodents. They're actually in the same family somewhere. They're cousins. And we're cousins to the kangaroo. We know this. And we're really closely related to rodents because they evolved parallel from diverging. So then you have the ape, and then you have monkey and human, okay? Closely on this line here, you have rabbits, squirrels, which are rodent type, okay? There's placentals and marsupials of these rodents. And this is why. See, sugar gliders, they're marsupials. And once you have the placentals here, and the monkey, you're going to have bats and Dermoptera, which is like a flying lemur, you know? And they're closely related in this lineage. So after we transition out of the marsupial stage, this is the whole area here where the whole lineage, basically, after it becomes ungulate from a bald animal out of the ocean, like hippo, because they are even-toed ungulates, and then passes a gene like a rhino, the horns and hair. After the keratin genes turn into horn and hair, we maintain a coat, except for right when we become humans, we start to lose it. You see what I'm saying? There's a short hair and there's a long hair. Like apes have more of a shag hair to them, whereas they have a antelope and bandicoot, rodents and stuff, super primate basically, or even some monkeys have a real fine coat to them. And eventually some monkeys actually get shaggy coats too, which is another kind of a divergence. See, if you have, all right, this right here is gene divergence. You have 1, 2, 3, then you have 6. I'm just this is an example, okay? So then this splits. Now you get half of one of the code, then half of the other. Then it keeps diverging, or well, it keeps advancing basically, and then it diverges into 2 here. This one's similar to this, and this one is similar to both of them mixed. You see what I'm saying? And then eventually this becomes this, which is very close to that, you know? So they're all related. Toward the end here, technically, the marsupials, rodents, and humans are all related because of this. Look, this is what they have, okay? They're not wrong, but they have it mixed up, okay? They're looking at it backwards. It needs to be reversed, okay? And see how these diverge, like I was saying here? Where you have the Dimoptera and the monkey, basically the placentals, you have bats. These guys are all closely related, and then the rabbit and other rodents here. But the marsupials are actually in here. Kangaroo, bilby, and antelope is even a little further than that, the ungulates. All the hooved, even-toed ungulates, and actually odd-toed. Because after all, genetically, the whale is an even-toed ungulate. Genetically. The cetacean. These guys are ungulates related to these guys. And we are 80% related to a bovine. Okay, we share 80% of our genes with bovine. Okay? I'm throwing this out here. I feel like people have to see it to believe it. Okay? You can look anywhere and find it out. Okay, that's why they're in the ungulates. They're even-toed ungulates. Okay, now look. With shared genes, we share 99% with rats, which has been published online. With working DNA, we share around 97.5 with rats and mice. Because this divergence here from a marsupial, we share that same lineage. And as time progresses, a parallel lineage evolves of each other. You know what I'm saying? So that's why we share the same genes so closely to cows and rats and monkeys and bats even. All right, now look. Now this kind of contradicts itself in a way. Bat classification is complicated because bats' tiny delicate bones make for poor fossils. It used to be thought that bats were actually closely related to primates. Dimoptera, okay, is bat and primate, okay, including humans. But recent genome analysis has classified them in a superorder that includes animals such as penguins and whales, okay? So they're related to whales. Okay, look, flying lemurs, okay, these we know are a supra-primate, basically. See, they're in the same family as the rodents. And we've always thought, well, a bat's a rodent. Well, I mean, people call them tree rats, too, just like squirrels. But squirrels are actually in this lineage here, too. And rabbits. So, we start from the ocean, placental live birth, 4-chambered heart. And it just stays 4-chambered heart, live birth, okay? Then the genes diverge eventually. So they do this over time here, too. And this, see, the manatee is more related to elephants and hyraxes. But the manatee has to be related to a cetacean and or a walrus. Or Odobenocetops. Okay, so regardless, the ungulates came from the ocean. Okay, the ungulates didn't evolve from a tree rat or a shrew. Okay, it's just that the shrew is in this lineage related to us. And that's all we know. Okay, so we say, oh, we had to have evolved from that, you know. But this family tree has always kept growing the same branch for hundreds of millions of years. The animals just slightly adapt And they're smaller because the atmosphere over that time, those hundreds of million years, starts adapting smaller animals, and smaller and smaller and smaller. That's why so many more animals were larger in the past, and now they're so much smaller. Now, at some point, gigantism was produced in the early Earth, okay, to give the metabolism to these animals. And then eventually, it started to regulate and level off, just like anything else would, in evolution, in a macroevolutionary scale. So just throwing this out here, this is another piece that falls into place. See, they're like nubs, okay? It's losing its horns, and the hips are evolving. See, notice that all these rodents always have the same kind of hips, the premature-like hips of standing up and walking on all fours. You see what I'm saying? It's all in the hips. See, the evolution of the hips have to evolve. If it's going to be a bipedal animal, it's going to have to be able to spread wide enough to be able to give live birth to a full-term baby. See, look, here's a kangaroo's hips. Okay, look how slender it is compared to an ape. All right, here's a chimpanzee. Now, I don't know if it's male or female, but it looks female, okay? And because most generally they show, whenever you look up hips and birthing, of course, obviously it's going to show up most generally female stuff. So this, I believe, is probably the female hips. Okay, see how the birth canal gets wider and the hips get wider? See the tailbone here? How it's much bigger and the hole's much smaller here? Because it gives birth to a underdeveloped baby and then just carries it in a pouch. So this is a premature stage. It's like premature birth in a way, but it's on evolution, a macroevolutionary scale. You know, it's evolution perfecting a bipedal full-term baby. And this is the stage it has to go through first. You see what I'm saying? And then it diverges into ape and rodents. But rodents, they keep this premature-looking hip. You see what I'm saying? How it's bent here. They don't have standing upright and straight legs. You see how when a baby is in the womb, its legs are bent similar to this. And over time, eventually they stretch and straighten out and it starts walking upright. But until then, the legs are similar to this, like a premature stage of evolution. Because the legs have to eventually evolve and the feet have to evolve, and then the animal can walk upright.